Welcome to the final exam, question number 27, and it says, select the correct statement about steel column base plates. And a steel column base plate is just a plate of steel, and here's your column. And it comes down to a footing or whatnot. And it may be a little bit wider, it may not, depends on what you need. But what it does is it distributes this load. It takes it, and then instead of distributing that load over, let me change colors. Instead of distributing that load over this area, it makes it bigger and distributes the load over this area, or that area. It depends how big your base plate is, and therefore you more look at that distribution as compared to this distribution. So as you can see, you have more, and if you look at it, and let's say you have a square footing, and you have that column coming in. This is a plan view. So instead of it, if you take this out from here to here, it would look like this, in green, and then the purple one would be out here. So you have more area to work with, and that means more shear area to work with. You have this entire shear area. It's kind of like the perimeter, and then if you don't have the base plate, you only have this much shear area, or that perimeter, to work with. And I hope when I say perimeter it makes sense, because that's this is what you're looking at. This thickness is what you're looking at for shear, that thickness of concrete. Then it's times the perimeter. That's times that perimeter. Alright, so let's look at our possible answers, which are A, B, C, and D, and we'll cross off the ones that are incorrect and see what we have left. Hopefully we have the right answer. A, they fix the column against rotation. Fix the column against rotation. I'm going to say negative. I guess they could, and that's not really incorrect, but I don't think that's what we're going for here. They could fix the column against rotation, but I don't really see a point where you would not want that column fixed anyways. So I think that's a no. They cannot resist any bending. They cannot resist any bending. Usually these are going to be so thin that you're not really going to look at them in bending. I hope that makes sense. Like this column is tall, and it's going to deflect like that, which is bending, and you're going to want your obviously it could really go either way, but so you're going to have reinforcing here, longitudinal reinforcing here, and I call it longitudinal reinforcing because it's going the length of the long side, and it's going to resist that bending, and if it goes that way, that will resist that bending. But that is so short, you're really not going to have any bending issues, so you never will look at bending in this very, very, very small. It's very, if you think of length as going this way, this is the length. I mean, if you have a length of 1 inch, bending's not going to be an issue. So I'm going to go ahead and say B is incorrect. C, they are designed to transmit shear to the foundation by friction. They are going to transmit the shear coming, if you look at this as shear, and it's going to create shear right here. But when it says by friction, that's incorrect, because it's by bearing. This is bearing. It's coming straight down. It's going to be a P over A type situation. So that's going to be no. So we think it's D. Let's see what D says. They are designed to spread the column load so that the bearing pressure on the foundation is not excessive, and that is exactly what we want the bearing plate to do. So D is our correct answer. And I don't have any further information right now that I think is really necessary. I think we kind of covered everything. So your answer is D, and I will see you on question number 28.